Hello everyone, how are you all doing? I hope you all are good. So today here we are back with a new video on our architecture series, and this is going to be video number 6, and it is going to be on architectural floors. So before I proceed further with architectural floors, I want to tell you the difference between floor and a slab. So this is very, very important. People don't understand the difference between a floor and a slab. A slab is a structural element which hosts reinforcement, and for resting a floor, a slab is required. So a slab is a structural element which takes a load of a floor on it. A floor is a finished surface that is visible to our eyes. And the other difference when it comes to Revit is that floor doesn't host any architectural floor doesn't host any reinforcements, as well as it doesn't allow us to modify the geometry of a structural slab. When I say a geometry of a structural slab, I will demonstrate that. So these are the number of activities which we will be doing it today to understand how effectively we can model a floor. So for modeling a floor, we will find the option in architectural tab here in floor. So once you take the command of floor, different tools will open, and here you can decide what tool you want to go with. As of now, if I select the square option for creating a floor, so here you can see that there is a closed geometry, and then this symbol specifies the span direction. So this span direction identifies the direction towards a longer span, as well as it defines the place or else the direction where the reinforcement is spanning, but this is only indicative. As well as there is the offset. And you need to understand one thing, that when you are modeling a floor, so floor is an element which will extrude downwards towards like it'll extrude downwards from the level. It won't be going on top of the level. For example, if I show you here in 3D, what will happen? See, this is a floor, and this floor has extruded downwards. Okay, and then there is this room bounding option. So if you enable this option, Revit will consider this as a closed geometry, and if you want to specify a name of a room or a number, Revit will give you that option. If you don't want this to be an architectural floor, here you can select the structural option, and it will host reinforcements in that case. So you can simply click on finish command, and then your floor will be constructed. What if I want to create a floor of such geometry which is at two different levels? Okay, so to create such levels, Revit gives us two different options. One option is you can select any of the boundary, and then you can select this option here, define slope. Once you select this option, define slope, it will ask you at what slope you want this side to be. Here you can see that there is the indication of this slope here. It means that this portion will be resting on top, and this portion will be resting at bottom. So I have given this as 10 degrees. And then here there is this other option which says constant height, defines constant height. So whatever offset you have given for this floor from that particular level, it will maintain that particular offset if you select this option, no matter what your slope is. Okay, and then there is the other option, which is slope arrow. As I have defined the slope using the define slope option, hence this option is disabled. But if I go here and take this floor, and if I go into edit boundary, you will see here that this option is active. I can simply draw a line here, and I can tell Revit that the level at the tail has to be 900 mm, and I want this portion of the tail to be raised up. See what will happen now. If I do this from this particular point, which is a tail, the floor has been raised up. Okay. But what is this particular activity? You can see here that there are there are walls which are resting at the bottom side of the slope. How that has happened? Okay. Now tell me one thing. Is it possible for you people to model a wall which is of varying depth? How difficult it'll be to create a wall in different sections. But here in Revit, you find that option wherein you define the slope of a floor and the wall will adapt that geometry of a floor. So as you see here that I have modeled a floor in 3 different sections. So I will go here in edit boundary, and once I simply close off that editing option, Revit will ask me, do I want these walls to be touching the bottom of the floor? If I say yes, attach, see, Revit has created a wall of varying depth which is resting at the bottom of the slab. Okay, so this is what this is how convenient it is to model a wall which is of varying depth. Okay, but you must be wondering how I have created a floor which is a single element but of 3 different sections. So again, you get this option here, modify sub elements. What I have done is I have used this option of add split line, and I have drawn a line here. How many lines are there? There are 4 different lines. So here I have defined the elevation, here I have defined the same elevation, so this has become one section. And then here I have defined another elevation which is 0, and here another elevation, so this has become one section. So it has raised up from this side and raised, and it is going downwards. So what has happened? A slope is created which you can consider it as a ramp. Okay, now there is another scenario here wherein there is a curved ramp, and I want to cover this entire portion. With a floor here. Again, just imagine how tedious will be to model a floor of varying depth, a floor of varying slope which covers the entire space right underneath this. Can you model it manually? First of all, you can, but again, I don't know how many hours it will take. But there is a technique which Revit provides us. What we can do is we can go in type properties. Once you go in floor assembly, see this screen I have already explained. Okay, so there's no point for me to explain this again. You can go and watch wall videos. You will get a clear picture how the screen works. So now simply I will be specifying another layer here, and let that layer be of any depth, it doesn't matter. But this option here makes all the difference. Variable, I will enable structural material as well, and then I will simply click here, variable option. I will specify the thickness as 150 mm, and now see what will happen. So this, let me tell it and see what will happen now here. See how convenient this has become. So now what has happened, there is a ramp which is a curved ramp, and I wanted to fill the space here right underneath this. So I have added another layer and enabled the option of variable. As I have selected the option of variable, what has happened? Revit has modeled a variable slope right underneath the curved ramp, and all the space is closed now. Okay, same thing we have done for this wall also. What we have done is we have selected the option of variable. Hence, what is happening? Revit is modeling a wall of variable depth. If you don't select that option, it will not be modeled. Okay. And then here, the last activity that we have is for this mass. And how you will create mass? And what is massing, that we will cover in the other part of the course. But I just want to demonstrate, like, if there is a geometry which is of very irregular shape, you can go into this massing option which is right here, and this will give you all the option for modeling the floor. For example, I have created this in place component, and you can see here that Revit gives me the option of creating a massing floor. A massing is just a geometry which is of any shape, which can be of any shape, as it can be of any shape. So you can't model a floor here manually. Revit gives you this option. If you select here, it will ask me at what different levels you have to create the floor, as there are only 2 different levels. So these are visible here. If I select 1 and 2, what will happen? Revit has created a floor here at those different levels, you can see here. But again, I don't see any thickness. It is just a geometry. So what I can do is I can go to massing inside. I can go to this option here, floor by face, and if I can, like, I will be able to select any floor from here, and then I will select this option which is a face, and then the other face I will simply click here, create floor. See what has happened. Now Revit has created a floor of irregular boundary, and it gives me the area as well as other features. So massing is very useful. I will be definitely creating a video on it as I proceed towards the architecture course, towards the end of the architecture course. So these were some of the activities, these were some of the methods of modeling the floor, and I really believe this video was useful to you people. Comment and comment on the video and let me know if you want me to cover some other part of the architectural course. At the end of the day, I will be covering the entire course, but again, and yes, as always, learners, let us rise and shine together. Definitely we will meet next week with a new video. Thank you so much.